screen share. Hang on 1 second. Can everybody see the screen? Can everybody hear me?
I can hear you, Sigrid.
Yes, indeed.
Hey, good, just checking. All right, thank you so much and welcome, and especially welcome if you're new to the club, if you've just joined, and if this is one of your first experiences of the club. This presentation is for you especially. And it's also a nice refresher for some of the people that perhaps know a little bit more. Oh, I'm getting, so a little bit about the New York Mycological Society, so you know what you've let yourself in for. We've been around for a really long time. The club was first founded in 1896, which means our 125th birthday is coming up next year. We were then refounded in 1931 by a man called William S. Thomas, who's a writer of a mushroom guidebook, and then once again reestablished in 1962 by John Cage and his friends. So we have our 90th birthday coming up and our 60th as well. So it's a lot of stuff going to happen over the next couple of years. And what we do is we find and document the fungi of New York City and some of the surrounding areas. And we do that all year round. And that makes us quite unique. There's really no other clubs in the United States that go out 50 weeks a year. And we do. And I think we're pretty proud of that. And we've discovered or sort of documented so far over 1,000 species for the 5 boroughs. Because when you think of New York City, you don't think of like it being a rich fungal habitat, but it is. It's kind of quite amazing how many fungi find a way of living here, and we're out there chasing them. So thanks for joining us and helping us do that. So one of the sort of basic questions we're gonna have to answer before we get into some of the more fancy stuff is like, what is a mushroom? Is it fruit? Is it a vegetable? Is it something you put on your pizza? Well, a mushroom is actually a small part of a much larger organism, the fungus. And most of the fungus is actually not visible. It's usually underground or in a log. And it's sort of these cobwebby white strands, and that's called mycelium. And it's got hyphae, that's sort of the individual little strands at the tip of it. And when that mycelium wants to spread beyond where it's currently located, it sends up a mushroom. And that mushroom is a reproductive organ, essentially. It holds millions and sometimes billions of little seeds called spores. And the wind sort of carries those spores away and helps that fungus sort of spread far and wide. So a mushroom is really like an apple on an apple tree, and the mycelium, sort of like the tree, except you can't actually see the tree, you only see the apple. So there's a sort of a much bigger story to what a mushroom is. Fungi are their own kingdom, so they're neither plants or animals, but they're actually more closely related to animals than to plants, to us actually, weirdly. They don't photosynthesize like plants. They digest food a little bit more like us. They sort of send out digestive enzymes and then absorb the sort of the result of it, except we have our stomachs on the inside and the mushroom has its stomach on the outside. It actually sends out enzymes into surrounding substrate. And then its cell walls are made of chitin. Chitin is also sort of the exoskeleton of shrimp, of insects, the scales of fish. So it's quite a tough substance, and it means that eating a raw mushroom is usually a bad idea because that chitin is actually super hard to digest unless you cook it. So how are you going to make a living if you're a mushroom? Well, there's several different lifestyles available to fungi. One is to be a saprobe, which really just means they're decomposers. And actually, mushrooms are responsible for more than half of the dead trees and dead plants have to be recycled, and the nutrients have to be made re-available to other plants. And fungi do that really important job very, very well. So this oyster mushroom right here is a saprobe, and it's doing that job. Fungi can also be the bad guys. They can be parasites. They can live on living trees and damage or kill those trees, for example. So they sort of extract nutrients and weaken the host. Or the most interesting sort of lifestyle that fungi are engaged in is mutualistic. It's sort of friends with benefits. It's called mycorrhizal. They form these amazing relationships with other plants, usually trees, where the tree gives the mushroom sugars, because mushrooms can't make their own sugars. And so what they get in return from the mushroom is they get phosphorus, other minerals, and water, because what happens is that the mycelium sort of wraps itself around the root of the tree and extends it much, much further than the tree could normally go by itself. So they get more water, more nutrients, and the tree is usually healthier for it. So these beautiful relationships is sort of one of the amazing ways that fungi kind of make a living and contribute to the overall ecosystem. A little basic mushroom anatomy, just so we all use the same words and know what they mean. This is your typical deadly mushroom here. That's Amanita phalloides. What's on top is called a cap, or pileus, if you're going to get all fancy. Underneath the cap, you see the lamellae, or the gills. They're these sort of little ribs that carry the spores. The spores are kind of attached to those ribs. The next thing is the stem, or the stipe. And that's often sort of at the bottom, sort of leads to a cup or vulva, not always. And some fungi, but not all fungi, also have a ring or an annulus, and we're going to go over some of them in a minute. So that's some of the basic language. And then just a little bit on development. I mean, a mushroom starts as just a little bundle of hyphae, a little bit of mycelium, sort of like in a pin. And that slowly grows and becomes larger and turns into, I guess, a button. And that button's completely covered by universal veil. But when the mushroom grows, that veil ruptures. And oftentimes what happens is then you get these little flecks and patches on top of the mushroom, like the famous fly agaric. And then the mushroom continues growing. And then you see there's a second veil, and that's sort of from the edge of the cap down to the vulva. And as the mushroom grows again, that also ruptures and leaves the annulus, and then you got your fully grown up sort of Amanita mushroom in this case. So not all mushrooms develop like this, but this is fairly typical. And this is where I hand it over to Ethan.
Okay.
Hang on, I'm going to stop sharing. Yep, Ethan's going to pick it up.
Okay. I think, nope, that's not the one. Where did it go? There it is. What Sigrid just talked about, can everybody see me? Am I?
You're good, Ethan.
Okay, thank you. Sigrid just described that development of a mushroom pertains to a very limited group of mushrooms in the genus Amanita. Not all mushrooms have a vulva, which leaves universal veil fragments on the cap. Not all of them have even a cap or a stem. There are a lot of different forms that mushrooms take. And so I'm going to talk about the form groups that we use. Form groups are a way that we organize and understand mushrooms based on their similarities in physical features, in their morphology. We in the New York Mycological Society, we frequently come across approximately 18 different form groups. And so we've organized these form groups in our own sort of idiosyncratic way. The form groups I'm gonna present to you don't exactly parallel entirely the New York Mycological Society system. And I've left a bunch out because there are some that it would take too long to detail. But you should know that the form groups themselves don't necessarily indicate a close genetic kinship of all of the mushrooms within that group. There are a lot of examples where mushrooms with very similar forms are not very closely related genetically. Would be an example of parallel evolution, where similar forms evolved at different times in different branches of the fungal family tree. But we put them together because they look similar, and previous mycologists also grouped them together because before they were able to understand fungi on a genetic level, they assumed that these relationships existed. So it's a continuation of that. As we discussed in the diagram of the development of the Amanita, the mushroom that springs to mind, the mushroom form group that springs to mind is the gilled fungus, the cap and stem mushroom, the kind that you buy at the grocery store and the kind that the caterpillar sits on in Alice in Wonderland. It is the archetype. It has, as Sigrid's detailed, the cap, and it has the stem, the gills on the underside of the cap, and often a stem. But in the gill fungi form group, there are examples where a stem is absent, like in the case of this Crepidotus. The mushroom will attach laterally from the side of the cap onto its substrate. So gilled mushrooms are in them, and as a form group are themselves highly, highly variable. We put them all together. They can be saprophytic, as Sigrid's detailed, parasitic, or mycorrhizal. And often confused with the gilled mushrooms, the form group that we usually look at next is chanterelles and their allies. They look very similar. Chanterelle itself, this is one on the left, looks everything like a cap and stem mushroom with gills on the underside. But in truth, those are not actually true gills. A chanterelle has these blunt gill-like folds that divide and anastomose, but are not true gills. But it is certainly the fertile surface where the spores develop. Other members of this form group don't even have blunt ridges at all, in the case of this black trumpet. And in this group, the entire group is mycorrhizal. They engage in mutualistic relationship with the roots of trees. Boletes are a form group that a lot of our members are very familiar with and love. They are much like the gilled mushrooms in that they have a cap and a stem, but rather than having gills on the underside of the cap, they have a pore surface. So the surface of the underside of the cap is speckled with all of these tubes, the ends of these tubes. And that is the hymenium, the fertile surface, the surface upon which the spores develop. This group contains some of your favorite edible mushrooms like porcini, and it contains relatively few dangerous ones, although there are a few. And one thing you should know about the boletes as a form group is that they're rather soft and spongy, and that you can separate that pore layer from the rest of the cap. You can really just sort of get your fingers in there and peel it away. Most of the boletes are mycorrhizal, except for certain very unusual exceptions. Similar to the boletes are the polypores, in that rather than having gills on the undersurface of the cap, the polypores have pores, but unlike the boletes, the pore surface out of a polypore can't be easily separated from the cap. Also, they're far more hard and woody or corky in most cases, except for the ones that we eat, of course. A lot of them will have a stem or a stipe, but many of them grow as a bracket where the entire length of their body is attached to the side of their substrate, which is usually dead wood or a living standing tree, by its full length, looking like a shelf sticking out of the side of a tree. But also they can grow resupinate, and resupinate just means that they grow completely flat to the wood, no cap, just looking like a branch that has been sort of wrapped in pores. Most of the polypores are saprophytic, though not all of them. Some of them are parasitic, extracting nutrients from living tissue. The next form group are the tooth fungi, which again look much like cap and stem fungi for some of them, except when you pick one of these cap and stem tooth fungi and turn it over, rather than having gills on the underside of the cap, there are teeth. The teeth hang down, and that's the surface on which spores develop. That's the fertile surface. But there are other forms within this form group that grow their teeth in a different manner, much less the cap and stem manner. Like this Hericium coralloides grows the teeth on the ends of coral-like branches. Hericium americanus, the lion's mane mushroom, almost just looks like a bunch of icicles cascading out of a tree. These can be saprophytic, parasitic, or mycorrhizal. Coral and club fungi, another form group. The name sort of says it all. They look like coral that you would find in the bottom of the sea. Either single club-like forms or branched forms. The fertile surface is the entire outside of the branch. Usually there's a little sterile area at the base. They are saprophytic and mycorrhizal. They can grow on the ground or they can grow on wood. And then jelly fungi. We have a lot of jelly fungi in our area, and we find them all year round. It's hard to go on a walk and not find some member of this form group in one of our walks. They look like a brain-like blob or an ear. They're very gelatinous and squishy. These are some of the descendants of some of the earliest fungi to evolve on land. These are sort of the ancient mushrooms. They mostly are saprophytic. They decay rotting wood, dead wood, but there are some notable exceptions. Fungi in the genus Tremella are parasitic, but not on plants. They're parasitic on the mycelia of other fungi. Puffballs and false puffballs. I've split this group up a little bit. Our club kind of lumps more of them together. But the puffballs and the false puffballs are familiar to most people with a basic knowledge of mushrooms. The spores develop internally inside of a stomach-like pouch. And then the spores are ejected in a dust-like puff, either from a pore that develops at the apex of the fruiting body, or just the outer peridium, the skin on the outside of the puffball will erode, allowing the spores to disperse through the wind. They can disperse by wind. They can disperse when raindrops hit the fruiting body and force the spores out into the air currents, or they can get kicked by children who come across them in the woods. That's pretty common. True puffballs, and that's what I'm highlighting over here on the left, are edible. But they're only edible if they are perfectly white on the inside. You cut a true puffball in half and you'll see white tissue that's almost the consistency of like an angel's food cake. If you see any indication of yellow or green or brown on the inside of a true puffball, then that means it's begun to sporulate and it's no longer suitable as food. False puffballs, like you see over here on the right, are poisonous. They have a far thicker skin, and when you cut them in half, they're usually not white on the inside. They are a dark purple brown, or if they've begun to sporulate, they're a dusty brown on the inside. False puffballs and true puffballs, this is a perfect example of a case of convergent evolution. These two forms in this form group, these two types of fungi in this form group are not very closely related genetically. False puffballs are far more closely related to boletes than they are to true puffballs. And some of them in this group, especially the true puffballs, can be mycorrhizal. Others are saprophytic. Stinkhorns, I broke them out of the Gastromycetes group that we usually use in the New York Mycological Society because I love them so much. Stinkhorns emerge very quickly from eggs, these egg-like forms that are buried in the substrate. You can see the top of one of the eggs that's broken open right here. And they grow very quickly, and their spore dispersal strategy is to stink. So they develop their spores as a sticky, oozing, gooey mass on some part of the mushroom. Here it is, the green stuff at the tip of both of these mushrooms. And the reason for the stink is to attract insects. The insects come and they eat the spores, they get the spores all over their bodies, and then they transport them elsewhere so that the stinkhorns can make more mushrooms. A lot of the stinkhorns we have in our area are sort of exotic. They didn't originate in North America. They arrived here as stowaways on plants that went to, or trees that went to nurseries that arrived here from Europe and Asia, or in mulch or in sod that came here from elsewhere. Next form group, crusts and parchment. Crusts are very subtle things that lay flat or resupinate on branches, usually dead branches that they're decomposing. There are, oddly enough, some examples of crusts that are mycorrhizal. They're on the outside of branches of trees, but they're merely using that position as a substrate, a way to elevate themselves for spore dispersal, where they're really actually below ground, participating in a mycorrhizal relationship with trees. It's a very unusual mycorrhizal relationship for something that looks like it should be rotting wood. Parchments, on the other hand, can look a lot like polypores. They'll create a bracket-like fruiting body sticking out of the sides of trees and wood. But on the undersurface, rather than having pores, they have a flat surface, no pores at all. It's a flat, almost featureless hymeneal surface. And finally, our last form group we're going to go over are cup fungi. And I've sort of fudged this one. We in the club treat cup fungi with a little bit more respect than I have here. Cup fungi is an extraordinarily diverse group if you're going to lump them all together like this, because there are examples in this form group that aren't even in the same phylum. And I've got two examples of that right here. This little cup that has little eyelashes around the outside is called Scutellinia scutellata, this scarlet eyelash cup. And it's an ascomycete in the phylum Ascomycota. Something sporting a very similar form, this much more floccose, hairy cup, Merismodes fasciculata, is a basidiomycete. So not even in the same phylum, but another example of coevolution, evolving the same form independently of one another. So those are our form groups. It's not an exhaustive list, but it'll give you a sort of a start. Oh, I've just put this slide in here as well. I forgot I had it. It's another example of parallel evolution. Here's a polypore, which looks like it has gills. So it's evolved a form that looks like gills, but really what it has is elongated pores. And here's another polypore, but it's more closely related genetically to the gilled fungal genus Lentinus. So another good example of parallel evolution, merging and confusing forms for us who are just looking at mushrooms in their macro features. Okay. So this is one of the first questions that arises for people who are new to the pastime of collecting mushrooms, either for taxonomic reasons or for the pot, is how do you identify a mushroom to species? Mushrooms have, just the gilled mushrooms themselves, have an enormous number of variety of forms, and there are just as many ways to describe those forms as forms themselves, probably even more descriptive words than there are forms. I'm not going to give you an exhaustive rundown of every single technical term for a mushroom form. That would be god-awful. But I'm going to give an example so that you can get a sort of a quick starter guide for identifying a gilled mushroom that you might have found. It's called, "So You Found a Mushroom, Now What?" This is a mushroom I found in Greenwood Cemetery. I chose this mushroom because we were doing that Greenwood lecture earlier today, and I wanted to make it Greenwood-centric, but it's a fairly good example. I photographed it from all angles, which is an important thing to do if you're going to show your mushroom to somebody else and you want to ask them to help you identify it. You cannot take a picture of just the top of a mushroom's cap from straight down and expect someone to be able to identify it. You need to be able to see all of the features, and so you need to photograph the mushroom from all different angles, getting as much detail as possible. So this is my mushroom growing in grass in Greenwood Cemetery. What should we do in terms of identification? The first thing you should look at is not actually the mushroom at all. The first thing to look at is the habitat. Take note of where the mushroom was growing. Growing on the ground, or is it growing from wood? If it's growing from wood, you have a pretty safe assumption that it's a saprophyte, something that's a wood decayer. Growing on the ground, it could be a mycorrhizal mushroom. But then again, you have to be careful because there are lots of instances where mushrooms that appear to be growing from the ground are actually growing from wood that's buried under the ground that you can't see. The other thing to take note of in the habitat are the trees that are growing in the area where you found the mushroom. If the mushroom is in a mycorrhizal relationship with the tree, knowing the tree might help you know the mushroom. But then we get to focus on the mushroom itself. First thing to look at is, let's just look at the top of the cap. Cap features. The top of your mushroom cap, if it developed out of a universal veil, might have these cottony warts on the top of the cap. Those are universal veil remnants, and they're easy. It's sort of easy to determine if that's what you've got because they brush off fairly easily. You can just sort of brush them off with a fingernail. Unfortunately, they also wash off in rain. So if they are a crucial feature for identification of a mushroom and it's rained, they might have completely washed away. As opposed to universal veil remnants, you also have mushrooms that develop scales, and the scales are a component of the cuticle of the cap rather than any part of the universal veil. And scales, in contrast to universal veil remnants, can't be rubbed off. You can't just easily rub them away. Mushrooms in the genus Armillaria, the honey mushroom, have apressed hairs, little hairs that are stuck to the cap. They also cannot be rubbed off. Other features, your cap might be viscid. Take note of whether the cap is striate or fibrous. Mushrooms in the genus Inocybe will often be striate. But if your cap is completely bald, then your mycological term for that is glabrous, a bald cap. Our mushroom from Greenwood Cemetery had scales on the cap and was growing in, the habitat was grass. Next thing you do after you've looked at the cap of your mushroom is flip it over and look at the gills. Gill features are very important to look at and understand. We're going to go over 4 manners that gills attach to a mushroom. In the upper left here with this brown spored mushroom and agaricus is an example of free gills. The gills are not attaching in any way to the stipe, to the stem. So if you follow one gill from the margin of the cap to its approach to the stipe, you'll see that rather than attaching to the stipe, it ascends and attaches rather to the underside of the cap, leaving this little ring raceway around the outside of the stipe. Those are free gills. In contrast to free gills, you might see a mushroom that has attached gills. That is, as you follow the gill from the margin to the stem, it is attached fully at the place where it hits the stem for the full length of its anatomy. A sort of variation on that are notched gills, where the gill sort of dips before attaching to the stipe. And then we also have decurrent gills, as you can see down here, where the gills run down the stipe for a certain portion or fully down the full length of the stipe. Also important to look at for gills is gill spacing. Here's an example of a mushroom that has distant gills and another with crowded gills. All right, what about our mushroom? Well, I didn't photograph it perfectly well because you can't actually see the gill attachment in this case, but this mushroom did have free gills. That one shows some more examples of features you might find on a stipe. And in this case, I'm highlighting boletes only because in boletes, the character of the stipe is very important. There's reticulation, where it looks like a little netting at the top of the stipe where it attaches to the cap. There's very deep reticulation. There's pseudo-reticulation. You can see here that there's sort of pigmentation that makes it look as though that there's a netted reticulation on the stipe, but there's no sort of actual 3D reticulation. And then certain members of the genus Lexinum will have scabers, which are these little black dots, often black dots on the outer portion of the stipe. But our mushroom was not a bolete, so we are going to move on and look at other stipe features, in particular, remnants of the partial veil that might have been left on the stipe. We talked about the partial veil. It covers the gills as the mushroom is developing. It's an important feature in many Amanita mushrooms because many Amanita mushrooms have a partial veil that leaves a ring on the stipe. But it's also found in a lot of other genera of mushrooms, not just the Amanitas. The persistent ring. Sometimes that persistent ring will even leave little patches around the margin of the cap. Another kind of partial veil you might see is a cortina. Cortina is a little cobwebby veil, little fibers that protect the gills as the mushroom is developing. These are often found in mushrooms in the genus Cortinarius, but you see them as well in Armillaria. When we had our ID session last Sunday, we saw one in a Satharella. That cortina will pull away from the margin of the cap and leave a little cobwebby ring on the stipe. That ring is very ephemeral. It can be washed away by rain or eaten by bugs. So it's one of those features that it's often not there. It's just missing. Mushrooms in the genus Pholiota have a very fibrous veil, and also in some instances very beautiful scales on the cap. And then this wine cap mushroom, we find this in the spring. It's coming out now. This is a wine cap Stropharia, and it has a veil that looks like a cogwheel, like the teeth of a gear, making it very distinctive and very easy to recognize. But of course, there are plenty of genera of mushrooms that have no veil at all. So you will see, you will look for other features about the stipe that you can latch onto. And I'm given as an example here, this is a Rula that has a rooting stipe. The stipe is often just as long underground as it is above ground. So you have to dig down and get that stipe out to see fully whether you have a rooting stipe. Okay, let's look at our mushroom. Our mushroom has a persistent ring on the stipe. Next, we're going to look at the remnants of the universal veil on the vulva. The vulva is as Sigrid described in the development of that archetypal mushroom, the vulva is the remnants of the universal veil that persist at the base of mushrooms in the genus Amanita, but also in the genus Vulvariella. We don't have very many Vulvariellas in our area, and they're sort of quite rare. But if you have an amanita, you might see a vulva with any number of these features and more. There are so many different expressions of the amanita via the base of the stem that it's a crucial part in identifying Amanita's two species. So if you're collecting something and you suspect that it's an Amanita, it's very, very important to dig down and collect the entire bulb, as deep as you have to go down to get it. And they can go quite deep into the earth. If you're just collecting Amanitas by cutting the stem off at ground level, then you're hobbling yourself in terms of coming up with any sort of identification. You've left all of the information you need to identify that mushroom in the ground. So dig up your Amanitas. What about our mushroom? Is it an Amanita? Does it have a vulva? Are there remnants of that vulva on the bulb at the base of the stem? It does not. You might have been fooled by this little piece of stipe tissue that broke away from the stipe. It sort of looks like it's a universal veil, but it's really more like a hangnail that the mushroom stem got. So no vulva. Next, take note of whether there is staining, bruising, discoloring, or whether the mushroom bleeds milk. Let's go over these features. Boletes often undergo a transformation where they've been scraped or damaged on any part of their anatomy. It can be the cap or the pore surface or the stem or the interior tissue of the bolete itself, or any combination of those or none of those in boletes. So that's an identification feature you have to keep a lookout for. When you cut certain boletes in half and expose the interior flesh to oxygen, they're undergoing an oxidation reaction. And that color can be a bright, stunning blue like you see on this bolete here. It can be red. It can be brown. Other mushrooms that are psychoactive contain chemicals that cause them to stain a sort of bluish green. This mushroom I found in Van Cortlandt Park is a Pluteus, not a psilocybe, but it contains this same compound, psilocin, that causes it to stain blue-green. And you can see it very subtly on the stipe. Other mushrooms rubesce, meaning they stain red when they're damaged, like this Amanita rubescens. There's a little spot here that probably was chewed on by an insect and it's getting red. And there are spots on the cap as well, on the stem as well. And as I mentioned, there's an entire genus of mushrooms that bleeds milk. We call them the milk caps. They're in the genus Lactarius. And mycologists will refer to this either as milk or latex that comes out of the mushrooms when the gills are damaged or another part of the mushroom's anatomy are damaged. And that color of that milk or latex can be a very important feature in identifying the mushroom. It can be white, it can be clear, it can be orange, it can be pink. And in the case of Lactarius indigo, it can be blue. So what about our mushroom? Oops, went too far. Our mushroom does discolor. It's discoloring where I've handled it here on the bulb, a reddish color. And you can see that those little sort of striations in the discoloration. Those are actually the impression of my fingerprint. So it discolors almost like an etched surface from the pressure of my fingerprint. And then finally, odors, taste, and spore print color. All also very important features to take note of when you've collected a mushroom. Many mushrooms have very distinct aromas. Smells like coconut. Numerous mushrooms smell like anise. There are a lot of mushrooms in the genus Russula that smell like shrimp. Others that smell like almonds or maraschino cherries. And as we discussed, stinkhorns can be very stinky. And one of them I know smells like soiled baby diapers. So take a big whiff of the mushroom. It's not going to hurt you, usually. Taste. The flavor of the mushroom tissue is also a very important diagnostic. And it's perfectly safe to take a nibble of any mushroom, even the most toxic mushroom, as long as you spit the tissue out after you've gotten the flavor. And in the case of very toxic mushrooms, it's probably also a good idea to rinse your mouth out with a little bit of water as well. But so there are distinctive flavors from sweet to acrid to very acrid, bitter to very bitter. And those flavors can be important diagnostics in identifying a mushroom. But finally, probably one of the most important diagnostic features, especially if you're just starting out learning about mushrooms, is the spore print, the spore color, the color of the spores in aggregate. You need to get the mushroom cap to drop its spores, and so that you can see what color they are. And there are mushroom spore colors that range from white to off-white to pink, which is actually sort of a pinkish brown. Very few mushrooms have a spore color of green, but the browns, the variations in browns are very numerous, from buff brown to chocolate brown to dark brown to purple brown to black. So our mushroom had this is it right here, our mushroom had a white spore print. But we're gonna pause before we go any further with our example mushroom and talk about spore prints and how to make them. If you don't know, it's a very simple process. You simply take the mushroom, cut the stem from the cap. You take the cap and place it gill side down on a piece of paper. And then some people put a droplet of water on top of the cap to keep it hydrated. And then you take a bowl and you put it on top of the cap, the mushroom cap and the paper, to keep the air currents from spiriting away the spores that are falling, and also to keep the environment inside that bowl sort of moist, which is conducive to spore dropping. And then you wait 2 or 10 or 24 hours, however long it takes. The mushroom will drop its spores, and you will see, like here, you will see the spore colors in aggregate. Our mushroom, as I said, had a white spore. Oh, I forgot about this, this slide. Very lovely image, which shows a section of a gill with all of its spore-bearing organs dropping spores into a pile as a spore print is made. Whoa, I forgot my slide. I'm sorry. Anyway, the big reveal. It was the big reveal on the identification of our Greenwood Cemetery mushroom. Let's just go back and I'll find it and we'll look at it one more time. Sorry about that. Zoom, share, there it is. What was our mushroom that we found in Greenwood Cemetery? It has scales on the cap. It has free gills. It has a persistent fleshy ring on the stipe. It has a bulb, but no volval remnants. So it is not an amanita. And it is a red staining mushroom. It rubesces. Answer to the question is, I don't know. It's definitely a Lepiota. That much we got out of the process of looking at all of the features. A Lepiota, which is a genus of mushrooms, which has free gills and a white spore print. But this mushroom, it's been suggested that it could be Lepiota americana, or it could be Lepiota cristata. I asked both Tom and Dennis for their opinions, and those were the opinions that they gave me. I wasn't fully satisfied with those, although I'm not a Lepiota specialist. The moral of the story is that you don't always get, sorry, I'm going back to my screen share. You don't always get to a species in identification. Certainly your field guides, which you will consult, can't contain every single mushroom that's out there in the world. And so if you're the sort of person who has to know the identification of everything, this might not be the hobby for you. I'm sorry, that was rather long-winded, and so I'm going to toss it back to Sigrid, and she's going to go over some of the common edible mushrooms that we have in our area.
Right.
Oh, look at that. That was the slide I wanted.
Yes, and I got it. Hang on. So can you see my slide?
Yes.
Yes, we can
Okay,
see the
good.
slide.
So yeah, so you've accumulated all this amazing information. You've been super diligent. The next step for you is you're going to get a field guide. There's a couple of really good ones around. We have recommendations later in the presentation about which ones to get. And so I'm going to ask you a bunch of questions about the mushroom you just found in terms of silhouette and other defining characteristics. And it's going to then point you to a bunch of pages within the field guide. You're going to look at the pictures, read all the descriptions, and then you're going to eventually figure out which one was the mushroom that you found, best case. So this is all really overwhelming, especially if you're new to mushrooms and you're going to go like, oh my God, I'm going to have to do this for every single mushroom. This is going to be so painful. So there is a bit of a shortcut. If you just sort of remember some of the mushrooms that are definitely safe and definitely not confusable with anything else, and then also learn all the mushrooms that are deadly and bad news and really not good at all. If you remember those kinds of mushrooms, you're going to be able to sort of navigate your way around the wood fairly quickly. So we're going to go over something called the Foolproof 5. It's actually 6, but it's 6 fungi that are hard to confuse and they're really good edibles. So let's dive in. But before we do that, just a couple of sort of reminders. Some people say, like, if you touch a poisonous mushroom, you're going to die or you're going to have to go to the emergency room. That's not true. You can touch any mushroom that you like. Don't bother going out into the woods if it hasn't rained for a month. You're going to be disappointed. And the time of year is also important. If you go in February, you're not going to find a ton out there unless you really know what you're looking for. If you're really into fungi, learning the Latin names is going to be useful, and we use some of them a little bit later. And then the other thing is New York City parks don't actually want you to forage. It's a bit of a gray zone, but don't walk around with a big basket. You know, be careful and be discreet. In terms of sort of preparing for a walk and then actually picking, it's like only pick specimens that are in good condition. Don't bother with stuff that's been a little bit bug-eaten or sort of past its prime. Stay away from busy roads or paths because there's a lot of contaminants that mushrooms can absorb. It's also like dogs, you know, like mushrooms are usually at dog level. Before you put mushrooms into your basket, sort of clean them up a little bit. You're going to thank yourself later because one dirty mushroom can sort of dirty up the rest of everything. Like we said earlier, make sure you cook them well. And some people have allergic reactions even to so-called safe mushrooms. So, you know, don't eat like 2 or 3 pounds of a mushroom you've never eaten. You know, eat a little bit first and then see how you do with it. So let's get to the first of the mushrooms that are very hard to confuse with anything else. This is a chicken of the woods. I mean, look at that. It's sort of like candy colored, really bright. They're a late spring to mid-fall mushroom. I found a beautiful one yesterday in Prospect Park, so they're definitely out there. They're either parasitic on live trees or saprobic on dead wood. There's a lighter version that's a little bit more orange called Laetiporus incinatus. There's one that's a little bit darker called Laetiporus sulphureus. This one is, I think, the latter. And they're best when they're really fresh. They have a beautiful texture, a little bit like chicken. But if you find an older one, you can actually sometimes rescue it by soaking it in milk overnight. So that's definitely one that's really hard to confuse with anything else. It's so distinctive. The next one is yet another chicken-like creature. It's the hen of the woods, Grifola frondosa. It's very much a fall mushroom. September and October is when it starts popping up. You find it often at the bases of older oaks. It's weakly parasitic. It rarely kills the tree. And they get really large. They can get up to like 10, 15 pounds. They pick up a lot of stuff as they grow. Like they contain sometimes leaves, sticks, insects, grit. So you definitely want to cook them well. They're also called maitake, and you can buy them in a farmer's market, and they're really, really good. It's a choice edible, the beautiful mushroom. And once you find one, there's a lot of it, so that's nice too. The next one is the giant puffball, Calvaceae gigantea, and it basically looks like a disassembled snowman. There's these big white balls that lie around in meadows and in forests. We very much find it in New York City. Prospect Park is usually full of them in the fall. They're decomposers, they grow in grass or on leaves. And like Ethan said earlier, you want to make sure that they're white and firm and not yellow inside or like completely eaten up. They're not that great in the flavor department. They're a little bland. Treat them like tofu. Add other things with it that are more flavorful, or bread them and fry them. Another mushroom you should definitely know, and that's relatively hard to confuse with anything else, are the chanterelles. And there's many different chanterelles. This is just one of them. It's definitely a summer mushroom. They start popping up in July, and they're once again a choice edible. They're mycorrhizal. You find them with oaks, with maple, beech, poplar, birch. They're like damp areas, often like mossy slopes. And they don't really have gills. You can sort of see that they have these folds running down this type, but they're not true gills. And if you open them up, if you break them open, the cap flesh is actually white, and they have this beautiful smell that's a little bit like apricots. So that's a good one to know. And then this is a mushroom that we find all year round. They're out there right now, but they're often out even in February or March when there's nothing else edible. It's the oyster mushroom. There's two kinds. One is Pleurotus austriatus, which is a little darker, more of a fall and winter variant. And there's Pleurotus pulmonarius, which I see a lot out these days, spring and summer. They're decomposers. They grow either on dead or live trees. And one sort of quirk is they actually also eat nematodes. They're sort of carnivorous. They don't really have a stipe. The gills run all the way down the stem to the point of attachment, and they're a wonderful edible. And then the last one, and we've been talking a lot about morels this season. We've had sort of 2 talks already about morels, but the one thing to remember is like it's very much a spring mushroom. It's usually the first thing that pops up in the mushroom season, April, May. It has a pitted cap. It's always hollow inside, never stuffed. And you find it under dying elms and ash trees and old apple orchards and under tulip poplars. And they're either mycorrhizal or decomposers. So they're a little sort of flexible about their lifestyle. So these are all fungi that you want to get to know. And just a couple more because we're at it. This one, the pheasant back, is out right now. And it's going to be out for quite a while longer. And it's an okay edible. But when it's young, it's not bad. I had one yesterday. It was actually enjoyable. It smells of watermelon rind. It has this weird and very distinctive smell, and it looks like a pheasant. I mean, it's very hard to confuse. The wood ear, you see that all year round, like literally 12 months a year. It's popular in Chinese cuisine. It looks like an ear growing out of wood. It's of a jelly-like substance, like stir fry it. It's decent. And then a price edible is the lion's mane. Ethan was talking about it earlier. It looks like icicles. It grows in the spring and in the fall and has a beautiful crab-like taste and texture. It's a little bit like seafood, and you can treat it almost like crab cakes. So these are all sort of edibles that are hard to mess up. I mean, there's really no other fungi that look like these. So even if you're sort of a beginner and if you can remember these, you're going to be okay. And just a little calendar, not for now, but it's in the presentation if you're interested in finding out what's in season right now, because oftentimes knowing what month of the year it is already tells you what to sort of look for and what to expect in the forest. And that's when I hand it over to Ethan. He's going to be the bad guy. He's going to talk about all the deadly mushrooms.
Muted. Sorry. Yes, exactly. I'm going to play bad cop and talk about, oh, I'm on the wrong slide. Sorry. It worked fine in rehearsal. Anyway, how not to die, mushrooms to avoid. These are the poisonous mushrooms that you need to know because you need to know to avoid them. One thing you might have noticed in the previous section of delicious edibles that are difficult to mistake for anything that might look like it, is that all of those fungi were not gilled cap and stem mushrooms. One thing when I took Gary's class many, many years ago, his advice was this: if you're feeling sort of tentative, if you're feeling like you're not very adventurous, like your skills at identifying edible mushrooms haven't quite developed yet, just don't eat gilled mushrooms. Eat the mushrooms that are considered edible that are not gilled mushrooms. And I took that to heart. I did, as I was starting out many years ago, I stayed in the shallow end and didn't sample things that could get me in trouble if I was not so good at identifying mushrooms. So this is the deadly Galerina, and it's a mushroom you need to know because it can lead to death if it is consumed. It is what mushroom enthusiasts refer to as an LBM, a little brown mushroom. This picture of it makes it look a little bit more yellow than I'm used to seeing it. But that might also owe to the fact that Galerina mushrooms are hygrophilous, which is a word that just means that they change color as they lose moisture. So when the conditions are very moist, this mushroom might be a darker russet potato brown. But as the mushroom dries out, it will lose that darker color in stages. So it'll almost look like a two-tone mushroom as it loses its moisture. You can find these mushrooms in the winter. I found them, we have found them in January in High Rock Park. They're decomposers, so you'll find them on dead trunks of fallen trees often. And these dead trunks will be sort of moist, like they're covered in moss and have a high water content. What could you potentially confuse this mushroom with? Well, if you're familiar with honey mushrooms, there's a possibility that you could mistake a honey mushroom for a deadly Galerina. This Galerina has a ring, so does a honey mushroom. It's got a brown cap, so does a honey mushroom. It grows on or with wood, so does a honey mushroom. Honey mushrooms, though, they have apressed hairs. They have those little stubby hairs on the cap. And also honey mushrooms have a white spore print. So another example where doing a spore print is a very important component of your mushroom identification, because if you think you have a honey mushroom and you do a spore print, the spore print turns out to be brown, then you avoided a potential trip to the hospital. Deadly Galerinas contain amanitin, which is a deadly compound, which we will discuss as we discuss this, our next slide of mushroom Amanita bisporigera, or the destroying angel. This is a deadly mushroom. It's got a smooth, almost glowing white cap. It has a annulus, a ring that remains on the very upper part of the stipe, and it has a vulva that's a cup-like vulva, and it's a summer mushroom, and it smells a little bit funny. I don't know how you would describe the smell. It smells a little bit funky. The Amanita bisporigera is ectomycorrhizal with hardwoods and conifers, and it develops out of a button, as Sigrid detailed in her discussion of mushroom development. There's a good image of a button right here. And as I mentioned about puffballs, true puffballs, you cut them in half and they're pure white inside, and that indicates that they're edible and not having spoiled. But also, if you cut in half a true puff, what you think is a puffball, and you encounter any features inside that look like a developing mushroom, then what you have could potentially be the button of a destroying angel, and you would not want to eat that. So when collecting puffballs, smaller puffballs like in the genus Lycoperdon, it's important to cut each and every one of them in half, not just to look and see whether that particular puffball is spoiled, but to make sure that you haven't collected accidentally an Amanita button. You can see beautiful outline of the gills here and the cap and the developing stipe, all surrounded by the universal veil. Destroying angel, a deadly dose for an adult human being could be as little as 1 cap. And people who have died from eating this mushroom before they died reported that it tasted delicious. So you can't use the flavor of a mushroom as a diagnostic as to whether it's poisonous or not. Symptoms of poisoning, after you eat this mushroom, symptoms may not start for 6 or up to 24 hours. And they include vomiting, bloody diarrhea, and stomach cramps. And then a very odd thing happens. After you've experienced these symptoms for a while, they abate. There's a period where the victim of the poisoning with Amanita bisporidura will feel a lot better. And so if they have been admitted to a hospital and they didn't really know what they ate in the first place, and so they were not able to convey that information to the hospital that admitted them, at that point, they appear to have improved. The hospital might let them leave. And that's unfortunate, because the next stage of poisoning with Amanita bisporidura is a relapse. There's a relapse that includes kidney and liver failure often. So I don't think there's any better way to put it. Don't eat this mushroom. In fact, if you are a novice mushroom collector, it's a good idea to avoid eating any Amanita. So as you begin to get the skills to identify different genera of mushrooms, you may come across Amanitas, and there are in fact good edible species in the genus Amanita. It's a good idea to avoid them when you're just starting out, because making an error in identification could be the last error that you make. The death cap is another Amanita mushroom, Amanita phalloides, that you need to avoid. It grows in the summer. It grows in partnership with oaks, and it has this sort of greenish yellow, it's really beautiful cap. It's almost, I see them and it's like iridescent. It's so beautiful, but it is deadly. Sometimes these caps can also be sort of a tannish brown instead of yellow-green. It has a veil on the stipe, and it has a persistent cup-like vulva. And this is an introduced mushroom. This mushroom came to us from Europe, probably at some point during the 20th century, with trees that were being imported to nurseries. This is a deadly poisonous mushroom, and just like Amanita bisporidura, it contains amanitin, and you would experience the same symptoms. Unfortunately, this mushroom, it resembles a mushroom that is cultivated and eaten, or collected and eaten, in Southeast Asian countries. So many of the victims of poisoning from this mushroom are immigrants to our country. And so that's quite unfortunate. I really think that there should be posters in the international places and airports that warn people about this mushroom as they arrive in JFK. And then there are jack-o'-lanterns. These are sometimes confused with chanterelles, but as we discussed with chanterelles don't have true gills. They have gill-like folds, these blunt ridges. And if you look at the gills on this jack-o'-lantern, you can see that these are true gills. They are like the edge of a knife. This mushroom is orange all over. It's also orange on the inside. So if you cut it open, you'll see the orange flesh on the inside. That's something that you don't see in a chanterelle. They also grow in a way that chanterelles don't grow. They grow densely clustered. Chanterelles grow singly, and they grow at the bases and on of dead stumps and of living trees. So they are saprobes. Chanterelles do not do that. If you were to eat jack-o'-lantern, you would experience poisoning symptoms within 1 to 3 hours. It's pretty fast. And those include vomiting, cramps, and diarrhea. It is not considered deadly, but if you ate it, you might wish you were dead. And another interesting thing about this mushroom is that its gills are bioluminescent. So if you happen upon it in the woods under just the right conditions in the middle of the night, you might see the gills glowing. The green spored Lepiota, Chlorophyllum molybdites. This is a poisonous mushroom that's fairly common in our area, in lawns and grass in the summer. In the hot months of the summer. I find this one in August. This can be confused with other edible species of chlorophyllum. It can also be confused with the parasol, Macrolepiota procera. But the difference between those edible mushrooms and this one is that Chlorophyllum molybdites has green spores. And so if you do a spore print, or if you wait for the spores to develop, you'll see that the spores are green on the underside of this mushroom. Chlorophyllum molybdites poisoning, it's pretty much, 24 to 48 hours of vomiting and diarrhea. Sometimes you can see this mushroom growing in fairy rings. I'm going to toss it back to Sigrid now, and she's going to talk about what you need to go mushroom hunting.
Yes, this is our final chapter. Okay, so you're ready to hit the forest or the park. So what are you going to need? So some of the essential equipment that you want to look at is, first of all, a basket or a bag. And normally I would say just get a nice big basket so you can space out the mushrooms, let them breathe and everything. But if you're going to go into New York City Park, you're going to be somewhat conspicuous. You don't want to bump into a park ranger with your big basket there. So sometimes a little bag can be more discreet. You definitely will want some paper bags because you're going to put individual mushrooms in there so they don't mix. You don't want to mix like a poisonous mushroom with an edible mushroom. And it's easiest to sort of keep them in neat and pristine condition if you bag them up. You want to look at a knife. You can use an ordinary kitchen knife, a small one, but if you want to get a little fancier, you could get a special mushroom knife. There's ones that have a little brush attached, which are great for sort of brushing off dirt. If you want extra credit, if you're going to get serious about your mycology, you definitely want to invest in a loupe because you're going to spend a lot of time looking at some of the smaller details on fungi that you can only see with a loupe that you're going to carry around your neck. That's sort of the signature tool of a true mycophile. And the other thing that a lot of us carry around with us are these tackle boxes where we can keep mushrooms separated, especially mushrooms that we're going to look at under the microscope later. So those are things you might want to invest in. The other thing you're going to need is a good field guide. There's a couple of field guides that a lot of people use. Obviously, there is sort of the grandfather of them all, the National Audubon Society Field Guide to Mushrooms by our very own Gary Linkoff. Gary Linkoff used to be the sort of North Star, the leading light of the New York Mycological Society. And it's a classic. It covers the whole of the United States. The Roger Phillips Mushrooms of North America guide also covers the whole of the country. There's a couple of good Northeastern guides. One is by Walt Sturgeon and Teresa Marone, and one's by Tim Baroni. And there's a few more. I'd be more than happy to consult with people about what guide to get. But those are like a good start. Just get one. You don't have to get all of them. And then iNaturalist is an amazing tool. It's a gigantic database in which millions of nature lovers record, identify, and share observations of any kind of natural life, including fungi. There are over 2 million observations of fungi on there already. And you're going to ask yourself, why would I need this? Well, it's really helpful in terms of helping you record what you found so you can remember it later. You can remember the name. It's also a great place to get your fungi ID'd, because there's a lot of people on there that will actually identify your mushroom for you. You can find out more specific information about a species you're interested in. It tells you the seasonality and the locations of where to find fungi. So it's a really, really useful website and an app as well. It's a very easy to use app. So this club, our club, has 2 projects on it. One is for the fungi of New York City, and one is for the fungi of just outside New York City. And as you can see, we've made thousands and thousands of observations. One has 68 people contributing, one has 46 people contributing, and we're always looking for more people to A, join those projects, and B, to actually start adding their finds to it. We're always really excited when new people share their discoveries with us. So please consider joining iNaturalist and joining those projects. How to do that, I'm not going to go over in detail now, but there is a tutorial, and we're going to share out this presentation. You can just click on that link and it'll take you to a tutorial on how to use iNaturalist. It's really very easy. And just so briefly about how to create a good observation. And this is not just for iNaturalist, it's also if you're going to post to our Facebook page or really anywhere where you want to share a picture of a mushroom. It's like, don't be like the person on the left. Don't have a blurred small mushroom that's hard to see. Make sure you show different sides of the mushroom, the discoloring, take a note of the smell, use good fresh specimens, like include a little bit of contextual info and so on. So, you know, good pictures are so important. We have these ID sessions on Sundays, and it's so disappointing when somebody has poor pictures and you're trying to help that person identify the mushroom and you just can't see enough detail. So the better the picture, the more likely it is that you're going to get an ID from us. Here's a couple of other resources. So one of them is the iNat project that I just mentioned. And like I just said, we have ID sessions once a week where people share their finds, open to everybody. We also have a very lively Facebook page. You don't have to be a member, but obviously you are a member. You can just post your pictures, give a little bit of information, and one of us will hopefully jump in and ID the mushroom for you. And then there's a bunch more resources. This is for when you want to download this presentation. And this is sort of the end. And there's a link here, but I'm actually also going to post it to the chat. I'm going to post a link to the chat for how to get a copy of this presentation, because then you can access all the other resources. So I'm going to click out of this, and I'm going to add this link to the chat. And that's it. We're done. We're open for questions now.
Thank you so much. That was awesome, you guys. So just if you have a question, you can either raise your hand physically. You can raise your hand next to your name if you open up the participants box, or you can put it into chat and just try to let everybody have a chance. So if it's not your turn to ask a question, please stay muted.
Right, and Max has a question already. For fungi outside New York City, I'm wary of sharing things from parks that are not visited, even in what are the regional limitations? So there's actually a map attached to the fungi outside of New York City, to that particular iNat project, and that map is fairly generous. It encompasses a lot of counties. It doesn't go quite as high up as the Catskills, but honestly, just post. Don't worry too much. We're always interested in seeing what's out there. So don't ever be reluctant.
In terms of like the legality and trying to stay within the stay legal in posting, I had in certain instances moved my my geographical location to just outside of the park, which, you know, is a little bit of a data fudge, but if anyone who is from the authorities happens to be looking at that particular observation, it does sort of keep you in a legal, you know, at least in terms of evidence of illegality, it keeps it low. I don't know if it works. Is that a bad idea? Anybody have an opinion on that? I'll take my answer off the air.
Do you mind if I unmute? I can totally remute myself. I'm sorry.
No, go ahead, Max. Go for it.
No, basically what, like I also do a very similar thing sometimes where I will post on INAT slightly farther away from where I've found a particular mushroom. But yeah, I mean, basically just what I was asking in the fungi outside of NYC, like I don't really know the restrictions because like I there's like the tri-state area and then there's like 2 hour drive. Like I don't know what's valid and what's not valid, and that's all.
Oh, in terms of the project, I'm sorry, I misunderstood your question. Sorry, yeah. Tom, do you wanna cover that? You're muted. Sorry.
Oh,
you're muted.
sorry. If you go to the fungi outside beyond New York City project page on iNaturalist, it explains what the parameters are, and it's basically any county in New Jersey or New York outside of the city where we do walks in the summertime. So it includes Westchester, Rockland County, Putnam County, and a few of the northern counties in New Jersey.
So we do the walk, we do a picnic with Coma in Connecticut sometimes. We went to Collis P. Huntington Park. Would that include Collis P. Huntington Park?
I don't think that we have Connecticut included in it. Because that's kind of a changing walk. It's not a.
That's basically all I was like talking about. If it's strictly the parks that are visited.
No, it's really any park in any of those counties where we do where the club does walks in the summertime.
Cool. Sorry to be real nitpicky.
Oh no, it's good. Yeah, it's a good question.
All right. What is the best way to clean harvested edible mushrooms from bugs and larvae hidden in pores? Does anybody have any tips? That's a good question. It's a question that often comes up. How do you get rid of the wriggly stuff?
I cut around it.
Some people put them in salt water. I mean, I know that. Some people just eat them.
I think the saltwater thing is pretty exclusively for morels, isn't it?
Oh, okay.
Because the tissue in morels is very dense and doesn't absorb water in the same way that something like a bolete would. So salt water it will scare the larvae out of the morels. But if you do that with boletes, wouldn't that sort of just make the bolete very soggy and unpalatable?
Probably, yeah.
Yeah.
Some people scrape off the pore layer of the bolete to sort of get rid of that.
You often find, like I look for chanterelles in Vermont, and chanterelles that you find growing near oaks, which are probably Cantharellus laterideus, the smooth chanterelle. They are pretty bug resistant. Like you don't find any larval channels inside the mushrooms you pick from those chanterelles around oaks. And then I also find a different chanterelle, and I'm not quite sure what the species is, and I'm sure the name has changed since we started this presentation. But the chanterelles I find around hemlocks are just run through with larvae. And, like every single one, channels of larvae. And I usually just sort of cut a little V-shaped notch around the little highway that the larvae are inside the mushroom, and then I use what's left over.
So Vincent has a great question, and I'm not sure whether I'll be able to answer it. Thank you very much for the presentation. I was in Orchard Beach forest last week, but I didn't see any mushrooms. Do littoral forests have more or less mushrooms, specific mushrooms? To be honest, I don't know the answer, but I'm hoping that somebody out there does. It was very dry in the last couple of weeks, and it's May is a weird month. May is usually a month with far fewer mushrooms than people think.
It's true. So is this Vince? Vince was at Hunter Island. Is that Orchard?
Orchard Beach, yeah.
Yeah. I don't know. We find a lot of we have collected hundreds of different species of fungi from that very forest. But again, yeah, it's been dry and it's also May. So, after the morels, there's kind of a lull, and there's a period where you won't see anything until true hot weather in summer and the season for ectomycorrhizal mushrooms kicks in, which should be mid-June, late June, early July. So you might have just been experiencing a combination of dry weather and the lull. Anybody else? Should we have a cocktail party? Everybody can get unmuted and chat?
That's a good idea, Ethan.
Okay.
Go crazy.
Sure.
Cheers, everybody.
Cheers. Good lecture.
Cheers.
All right.
And by the way, this presentation was recorded, and in the next few days, it will be posted to the NYMS YouTube page, where you'll be able to see it again. We'll send out a link when it's ready.
Oh, lovely.
Oh, Kay has a question. Explain how maitake in particular can get full of grit after rain.
Good question, Kay.
Who wants to go at that? Well, I'll go. The rain hits the ground, the dirty ground, and as the droplets splash up, it makes the dirt on the ground sort of splash back onto the pore surface of the developing maitake. And then the maitake continues to develop, and it can often sort of envelope those little pieces of gravel and grit and make it a very unpleasant experience. So Paul has a good piece of advice that I've taken from him, which is if you find a maitake in the woods, before you go to the trouble of hauling it all the way home, especially if it's a rather large one, take a little nibble of one of the caps. And if you experience any abrasive feelings in your chewing on that cap, it may be that the splashback from the grit on the ground has ruined that particular maitake. That's the best I can do. Anybody else?
I always assumed that the mushrooms kind of pulled the soil up from the ground as they were growing.
Yeah.
No.
No?
Probably not. No. You often find they'll grow up through leaves, so that as they're developing, if there are leaves on the ground, they'll sort of push them up and out of the way, but they'll also sort of wrap the tissue around them. So you often have to pull a whole part of a leaf out of a fully developed cap. Maitake season is wonderful, but it's also, you just sort of have to set aside a lot of time for cleaning.
There's also kind of a scientific principle that many mushrooms already have all the cells when they're in the primordial stage, right? And then they just expand as they increase with water.
Amanitas, for instance.
Amanitas, for instance, as Tom is saying. But maitakes don't do that. They keep producing cells. And so they're encompassing what is upon them and around them as they continue to mature.
They're indeterminate.
That's right,
Right.
Kay.
In between.
Judy is asking, when did the common name maitake take over from hen of the woods? Maitake is the Japanese name for that mushroom. Maitake, taki is mushroom, and mai means, doesn't it mean dancing? It's the dancing mushroom. Tom, you're muted. So it's the dancing mushroom, maitake, because when you find one, you do a little dance because you're so delighted that you found one. And you're missing an A in maitake, M-I-A-T-A-K-I.
Okay, so I'm going to ask my question now, unmuted. But when I was younger, I learned hen of the woods, and then it seemed like everyone just started calling it maitake. Like
I would guess that coincided with their commercial availability in supermarkets.
Okay.
Sounds better.
Also, depending on where you are in the country, they're called ram's head. Do they call them that in West Virginia? I think in Ohio they call them ram's head. So the name kind of
Never heard of that.
depending on where you are.
Right. Right.
That's one of the confusing things about common names is they can vary from region to region.
Confusing, but a little delightful.
Yes.
Catherine is asking if there's a lull in chicken of the woods right now, and I would say not, based on the pictures I'm seeing posted on Facebook. It seems like they're very, very abundant, although I've not had any luck myself.
Yeah, I saw them. I saw one in Prospect Park that had developed a very beautiful, fresh chicken, and someone stepped on it, put a big boot print right in the middle of it.
Thanks for the maitake explanation. I think marketing is the answer.
Marketing seems like it's always the answer.
May I explain a little bit about maitake?
Oh, please do.
Mai is a dancing and taki is a mushroom.
Uh-huh.
So it's a dancing mushroom. Mushroom is not dancing. People dance.
People
So-
dance, right?
In the old medieval times, the Japanese lords offered some money to the peasants when they found them. So when the peasants found the maitake, they were so glad that the rewards were offered. So they danced. That's
Oh,
why
they
it's
were-
called dancing
Oh,
mushroom maitake.
I didn't know that it had to do with money and not the flavor of the mushroom.
Money and marketing every time.
Yep. So, and maitake is a mushroom that is native to Japan, right?
Yeah, I
And
guess.
we have it here on the East Coast in the US, as far west as, say, who's going to help me with the range here? But maitake you don't find on the West Coast much, do you? Anybody? You're muted.
I think they're uncommon.
Uncommon on the West Coast.
Yeah, much more common here. I think they are found, but they're not as common as they are here.
And then they're completely devoid. They don't exist in Europe at all.
I think they do.
Oh, they do.
They do. I think they are.
Oh, they do.
Yeah.
I'm thinking of a different mushroom then.
But again, they might not be as common in Europe as they are here.
Yeah, it's true. I've never found them, but I've seen them in European mycological book. They do have
Yeah.
Mm.
It's Bruce. Definitely not found in the Rocky Mountains, nor a chicken of the woods.
Very good. Well, yes, and people on the West Coast also have a very different relationship to chicken of the woods than we do on the East Coast. We hunt them very avidly, and we are delighted when we find them. But on the West Coast, not so much, because there are poisoning incidents or at least allergic reactions that happen more frequently on the West Coast. Isn't that right?
Is that because of the trees they grow on? Because they are growing on pine?
Yeah.
Yeah, the conifers, yeah.
Aromatic woods can sort of be problematic with digestion, I think, with some species of chicken of the woods. But of course, you know, not an authority on West Coast mushrooms by any stretch. So consult with someone who knows.
If I may, do you think that the morels are now completely over, or we still could find some?
I suspect that they're over here in this area, but if you go up north of it to Massachusetts, you may get lucky.
Okay.
Or just even farther up in New York, if you go up, past Albany, they're probably out. Higher elevations and farther north, they'll still be out.
You can keep following them all the way.
All the way to Labrador.
Yeah.
Yep.
Yeah.
All right. Did we lose it?
And Sigrid, you found the first mycorrhizal mushroom of the year.
Oh, the Russula from Greenwood. Well, I want to call out Potter, who found the first bolete in Greenwood yesterday. It was actually Suelas. So yeah, mycorrhizals are in.
Wow,
Awesome.
that's exciting.
It's Greenwood.
Right.
Place to be.
It is.
Have to get up to Woodlawn and see if the Amanita muscaria are out.
Yeah.
It's around now that they come out with the Norway spruce up there.
Yeah. Mm.
Thank you guys. This was great.
Good to see you, Kay. Alex, what is a deer shield mushroom?
A deer mushroom, like a
Oh, you mean Pluteus cervinus?
Maybe if it's deer shield, it's a pheasant back, squamosi.
Yeah. Oh.
Deer.
So Pluteus cervinus. I'm looking in the chat, Juniper.
I know. I was just thinking. I was just guessing that.
Okay.
It just sounds like deer shield. It sounds like squamosis.
Right. Well, Alex, you should join us for our ID session, and then we'll all take a look at it.
Yeah, put Pluteus cervinus. Deer shield. I'd never heard that name before.
Hmm.
And Pluteus cervinus, they've been coming out for at least a month now in the city. They've been out for a while. We saw some yesterday in Van Cortlandt Park.
Yeah. All right.
When's the ID session?
Sunday.
Sunday. I'll send out an email about that probably tomorrow.
Okay.
But it should be, I mean, we were in Van Cortlandt yesterday, and there's a lot of stuff starting to come out. So get out if you can and come to the ID meeting, and I think we should have a lot of stuff to look at.
Exciting.
And some actual guild mushrooms and some mycorrhizal mushrooms.
Amy Lee did it just for our last one here. She has a good question. Mushrooms can be inedible due to the region it's in, even if it's a known edible. I think that was about the chicken mushrooms in the West Coast.
There are people who warn against eating chicken mushrooms that grow on eucalyptus in the West Coast, because apparently the combination of compounds that the mushroom absorbs from the eucalyptus wood can trigger an allergic reaction in some people, I think, or in certainly more people than average for chicken of the woods on the East Coast. Has anyone looked into that any more than I have?
I think that's right. It's eucalyptus. Eating chicken mushrooms growing on eucalyptus will probably make you sick.
But it's certainly, we are very sort of East Coast centric, and so I don't really know all of the ins and outs of Laetiporus that grow on the West Coast, but they certainly don't get as excited about them as we do here.
Right. And there's another one that grows in Michigan, Wisconsin, Gilbertsonii.
That's the one.
It grows on hemlock. And I don't think that's a good edible either.
It's not a good edible in what sense?
It has a tendency to make one sick, I think.
Right.
But it's not one that we have around here. We only have the two that are, generally considered to be great edibles unless you have a allergy to them.
Right.
And the allergy can be, like, Ethan, do you get a numbness?
Yeah, actually.
A lot of people get that, and that's kind of the mild form of an allergic reaction to it.
Right. Anybody else get that? You eat a chicken and you get a little tingling in the lips, a little numbness.
I get a vicious reaction.
I know that. That's not what I was asking. But yes,
yeah. So there's a small percentage of the population. I've met a few people who have, like me, a very bad reaction hours later. You don't realize it's coming and you've been asleep and it comes on. So always be careful.
Yeah.
And that's true too. It can be true with many different mushrooms if they're not thoroughly cooked too. Morels are generally great edibles, and if you undercook your morels, chances are they'll make you sick. And that's generally true with just about any edible mushroom.
And there's also the story of Michael Kuo, who ate so many mushrooms of all different sorts that he has developed a sensitivity and can no longer eat mushrooms.
Yeah, that's a pretty common
look
thing
out.
too with people who eat too many.
That's right. Don't eat too many mushrooms.
Yeah, I've actually gotten sick 3 times from honey mushrooms. And one time at a foray when no one else became ill. It was actually a NAMA foray. And I was the only person because I'm obviously sensitive to them.
Yeah, I've heard of people being sensitive to them. And the honey mushroom too is also one that you really have to make sure it's thoroughly cooked. Because they'll also, if you cook them rare, they'll make you sick.
Right. No stir fry. No quick stir fry.
Yeah.
One more question from Vincent. Do you have any idea when we will start the group walks again? Now, that's a question we all would love to answer.
No, the answer is no idea.
Yeah, whenever it's, safe, we will. But until then, people should go out, even go out with a friend or 2 or 3. But we're not going to be having any of our walks where we, might expect 30 to 50 people to show up.
Right.
It's not really safe. The mushroom hunting is a very social activity, and there's a lot of interaction and passing things around, and it's just not a good idea to start doing it in the way we normally would until it's really safe to do so. Hopefully soon. Month, 2 months, who knows?
Yeah.
But yeah, it definitely go out.
And bring your finds to our ID section.
Yes.
Yeah.
Is that a mushroom face mask?
Who has
I know.
Who has it?
I missed it. Who has it?
Alan.
Alan. Oh, okay.
Let's see it.
Oh, I'll spotlight. Hold on.
There it is.
Ah, great.
All right.
Very nice.
I never knew what to do with this stuff.
Make it yourself.
No, someone made it for us. We have matching ones.
It's very nice.
Yeah.
Required for the mushroom walk.
You bet. Okay, I'm going to sign off and
Thank you very much.
Thanks a lot. That was great.
Thank you.
Wonderful.
Thank you both. It was really fun.
it was really a pleasure.
Thank you.
Good seeing you all.
Good seeing you.
Yeah, nice to see everybody.
Yeah.
See you all on Sunday.
Come on Sunday.
Yep.
But now the talk show.
Yes.
All right. Bye.
All right.
Bye.